One of the things that I want to give frequent feedback on while graphing these is label the axis. You have to label the axis. So when we are the ones graphing, we get to alter how that is drawn. We talked about on Thursday and Friday when we looked at writing equations of looking at a picture. We don't have control over how it was graphed initially, so we kind of have to go with what they have. And they may not mark it the same way we would have. But when we are graphing, we make our decision. When we are graphing, we start with B, and that is the first thing that I will adjust on my graph. B tells me what to mark my tick mark as once I have converted it into the period. B is 4, therefore, I'm sorry, B is 2. Therefore, the period, 2 pi divided by B, is pi. That becomes the marking on my tick mark. Again, because I'm the one graphing it, right? If they graphed it, they may not have chosen to adjust that. So, label in the negative direction as well. Have to have at very minimum that fourth tick mark labeled as pi. I do have a vertical stretch or an amplitude of 2 on this one, which means if I just label my y-axis in ones, I should be fine. After that, there are no other transformations. My midline did not move, so it is still here on the x-axis. It is a sine curve, so start on my midline. No phase shift, so start at the y-axis. Go over my first tick mark of my amplitude of 2. Return to the midline. Down my amplitude of 2. Return to the midline. Fill in my pattern the other way. 2 below, midline. 2 above, midline. Nice curve. Making sure to alternate all the way across my graph. Questions on that? Every now and then I have somebody a little hung up on the directions of graph 2 periods, and that bothers some people. Guys, we just fill in the whole graph always. So just always fill in all the way from the left end to the right end, just like you normally have, and it will take care of that whole graph 2 periods with the graph thing. Okay? Don't get hung up on those graphs. All right, today and tomorrow, you are finally going to get introduced to your last 4 trig functions. Today, we are going to focus on secant and cosecant. Tomorrow, we will add in tangent and cotangent. One of the things that we need to understand when looking at a graph is the slope of a vertical line. What would you have described the slope of a vertical line as? Undefined, right? If I were to describe the slope of this line right here, I would call it undefined. If my function is hitting the x-axis, that is where it is equal to 0, right? We call it a 0 or an x-intercept. So this is where my function equals 0 is a dot on my x-axis, and kind of the combination of those 2 things is what will lead us into our graphing of our reciprocal functions. I just want to make one more comment before I move on. If I were to describe something as undefined, remember that would have come from a number over 0, right? If we are looking at fractions, that's when I simplify it to the word undefined, is that the 0 would have shown up in the bottom of the fraction, okay? Any questions so far? Okay, so the graph of cosecant, the graph of any of our reciprocals. What we're going to do is look at how it is related to sine and cosine. Cosecant being 1 over sine. When you are graphing one of our 4 reciprocals, like I said, you'll focus on your sine and cosine, but you'll focus on specifically the denominator. And what we're going to do is we will start to graph these by dotting out the denominator. Okay, always. It doesn't matter which of these you do. You will start by dotting out the denominator. In a cosecant, our denominator is sine. And so what I do is I come over and I just grab that sine curve that I know how to draw. Our sine curve starts here at my midline, over and up one, back to my midline, down one, back to my midline. Fill in. Okay. So had I put the curve through that, it would look like a sine curve, right? I'm not going to. We're just going to dot it out. And then I want to remind you that every single one of these dots right here that is on my x-axis means that sine of x equals 0, right? So every time sine of x equals 0, if I were to replace this with a 0, cosecant would have actually been described as undefined, okay? So now we go to step number 2, and every dot on our midline, we have 1, 2, 3, 4, 5 of those, we will then put in a vertical asymptote because it is undefined at that point. Undefined is vertical line, so that's not a value for cosecant. So at all dots on midline, all of these dots that we have on our midline where sine equals 0, making cosecant undefined. We will draw in a vertical asymptote. Every time sine is 0, cosecant is undefined, and in a picture, what undefined looks like is a vertical asymptote. We don't have cosecant value there. Okay. Cosecant is the reciprocal of sine, right? So if we look at turning the sine value upside down, our sine curve, like let's just look at this little section right here. Our sine curve would kind of look like if I were just to consider that little part, kind of like a little parabola, right? An upside down parabola right there. If I were to connect it in my sine curve. And if I turn that upside down, it's going to still look like a parabola. And I want to show you even more. Like right here, sine has a value of 1. If I turn 1 upside down, it's still 1. And so that actually ends up being my first cosecant dot. If sine is like a half, which would be right here, the reciprocal of a half is 2, and ends up here. Okay? And so what happens is we will use these dots right here that are off our midline to start our cosecant curve. The rest of it is taking that little parabola and turning it upside down, and you get a parabola going away from your midline at each of those dots. That is half of a cosecant curve. The other half would be completing one below our midline. So I use the dot off my midline, and I draw in a parabola that goes away from my midline. The two I have right there would complete one period of a cosecant curve. So at the dots of the midline, you use that dot and draw a parabola away from the midline. Okay? And I fill that in all the way across my picture. So every dot that is off of my midline, I use it to start my parabola that's going to go away from my midline. Dot off of my midline, parabola away from my midline, and you fill that in all the way across. Dots on our midline are asymptotes. Dots off our midline are for parabolas. Questions? Okay. Same thing for secant. Secant, again, we would start by the denominator. Always start with your denominator. It is the exact same steps I just put on the last page. Is that we dot out the denominator to start. You have to remember what the denominator is. For secant, that would be cosine. So I come over here and I put my dots for a normal cosine curve. changes because I'm doing a secant instead of cosine, because now I don't connect them, but I will look at these in a different way. The dots on my midline, so those four, become my vertical asymptote. So I have four vertical asymptotes in this picture. The dots off of my midline become the start of my parabola, and my parabola always goes away from my midline. So if it's below my midline, my parabola will head down. If my dot is above my midline, my parabola will head up. And we fill all of those in. On the outside, oh yes, sorry. Oh yes, on the outside, you can do this one of two ways. Ultimately, you need to fill in between all asymptotes. If you did this bare minimum, that would be enough. You will always see on mine that I finished this out using this dot here. Now, I only put one half of it because I don't have an asymptote on the other side to follow. But if you were to put the whole parabola, it's completely fine. I don't mind if you put the whole parabola there. I'm just saying what you'll see when you check my work on my amplities is that I tend to go to my very outside ones and just put the part that goes towards the one asymptote that we have drawn. If you put a full parabola out there, great. If you don't fill in the outside ones, great. As long as you have everything between the asymptotes that we have, you're good. Question. Okay, here's the great part about our technique for graphing this. Again, this would be one period. It's the same as if it was a sine or a cosine graph. It's 2 pi. It takes that amount of time to get both an up and a down parabola. Not something that you super need to know, but those four all have the same truth. This technique of graphing our sine and our cosine, secant and cosecant today, makes doing the transformations really easy because we just follow graphing our transformations for sine and cosine and then fill in the difference at the end. The amplitude is the distance between your midline and that bottom dot that happens when you draw your parabola. You don't have to make any other adjustment. And again, because of how we graph these, you won't really even have to worry about that. If you just graph your sine and cosine, how to, it will take care of drawing any amplitude. But that's what they're talking about when they're talking about a secant or a cosecant graph, is our cosecant from that starting dot away from our midline. So how do we graph this? Something with a transformation, like the one we did in our warm-up. Y equals 2 cosecant 2x. What I do is I consider the denominator and I would actually graph this, and I would put a parenthesis, but I'm not going to actually graph it. I'm going to dot out to replace the reciprocal sine 2x. Okay, and I'm going to dot this equation. But I'm going to dot it like I would have been graphing it last week. Okay, so all transformations will apply just like I would have applied them last week. So we can kind of go through this a little faster because this was our warm up and we already talked through how to do this one. We said that B was 2, so we took our period 2 pi divided by 2 was pi. And our amplitude was 2. We just labeled by 1 there. Our midline did not move. I will still draw in my midline, just like normal. And just like we did in our warm-up, I am dotting out the reciprocal of cosecant. And cosecant is 1 over sine. So I always think about the denominator. Dot out a sine curve with an amplitude of 2. So it is like we are doing the warm-up all over again. The only difference is, instead of connecting those dots here in a second, we're going to do what we now learned about cosecant. Okay, so dotting out my sine curve is where sine stops. And we pick up cosecant. Cosecant, I now use each of those dots on my midline and draw in an asymptote. use all of the dots that are off of my midline to draw a parabola. If I have a dot off of my midline here, it is above my midline, so I would go away from my parabola, or away midline up. This one is below my midline, so I go away from my midline below. Up and down. And notice on this, we had an amplitude of 2, and that shows up right here, taken care of by how I graph the sine curve. Okay, so you do not have to do any adjusting if you just think of it as graphing 2 sine to x. So basically, I'll go through each time and just think of what is its denominator, graph that instead. But instead of connecting the dots, I use them for a slightly different picture. Question. Easy enough. Oh. We just got a couple to practice here. Let's do a couple other transformations. Cosecant of x plus pi over 4. So again, the first thing I'm going to do is consider what is reciprocal. Because cosecant reciprocal is 1 over sine x, I will choose instead to look at this as sine of x plus pi over 4 and dot out that graph to guide me through my cosecant graph. Now, the only transformation on this one is the which direction? Left. Pi over 4. So my numbering is not going to change. Pi, negative pi, 1 down to -1. This one is always a little tricky when our transformation or our shift, our phase shift moves us between dots. But I should start this sine curve to the left, pi over 4. So my first dot falls between the 2 tick marks that I have in this picture. Are we okay with that? Which means all my tick marks fall between, or all my dots fall between the tick marks now. Because now to go over 1, up 1, over 1 puts me between my 2 tick marks here, up 1, between my 2 tick marks back to my midline, between my 2 tick marks down 1, between my 2 tick marks back to my midline. So I'll pause there for a second. Are we all okay with that? Yeah? Okay. But I fill in the rest of my pattern. All of my dots falling between my tick marks because they all only got shifted a pi over 4 to the left. And then we just now shift from connecting the dots instead to drawing asymptotes and parabolas. Okay? So use my 5 dots here on my midline. To draw in my asymptotes. Asymptotes are a requirement. Okay, so sometimes we talk about things that are not required. Those ones you have to draw. And parabolas, hit those dots that are off my midline, go away from your midline. Questions? Okay, so we're going to make sure we hit the rest of our types of transformations. Yeah. We'll see an ROX on this one, and then we'll have one more where we have a Two things again. Consider what the reciprocal is. And also a reminder that if you have something like x over 2, you can slide that x off to the side, and that is 1/2 x. Okay, so instead of looking at it as -3 secant of 1/2 x, I would consider the equation -3 cosine of 1/2 x and dot out that picture to get my graph started. So we do have a change in our labeling here. B equals 1/2. Therefore, the period to pi divided by 1/2. 2 pi times 2 over 1 is 4 pi. a amplitude of 3, and so I need to make sure that I can get up to 3 and down to -3. We don't have a shift on this one, a vertical shift on this one. So I'm going to go ahead and just label up to 3. Okay. We don't have a vertical shift on this one, so my midline is not moving. So here at the x-axis, it is a cosine curve. So remember what an ROX does to a cosine curve is it starts below the midline, the distance of the amplitude. Well, I'm in my amplitude, I put that as my first two parts here. So our starting dot for this cosine curve should start down here at -3. The distance of the amplitude. Any questions? Okay, now fill in our pattern. To my midline, 3 above. To my midline, 3 below. And remember, we're just dotting. And now we switch gears to drawing a secant graph instead of a cosine. Asymptotes are all of the dots that are on the midline. Parabolas at all of the dots that are not on our midline. So, again, ROX, did I have to do anything different? No. Continue to graph sine and cosine like you have been practicing for an entire week. Okay? Any questions? It takes care of 100% of your transformations if you just apply all of those transformations to your dotting out of the denominator. All right, last one. We need to get C1 that has a vertical shift in it. But again, if you follow our rules, it is not going to change anything that you do. Consider the denominator. Dot that graph out instead. So we are looking at a secant, which means the denominator is cosine. And so instead of graphing this, I would start by graphing cosine of x plus pi minus 1. Again, start with our normal pattern here. So B is 1, therefore normal period of 2 pi. I have a vertical shift of down 1 and an amplitude of 1. So as long as we get to 2 on our y-axis, we're good. And then once I have my numbering, we start with the vertical shift. This is our one and only example of a vertical shift on this one. So my midline will be down at -1. And again, not everything is relative to that midline. We do also have a phase shift on this one. Again, plus pi. Is going to move us left. Pi, so my starting dot for this cosine curve, which normally would have started 1 above my midline, is actually going to start left pi 1 above my midline. And now we just fill in our pattern. So I'm going to go to my midline, 1 below, to my midline, 1 above, to my midline, 1 below. Okay, now notice, guys, there's a difference between the dots that are on our x-axis and the dots that are midline. It's that everything is relative to our midline, right? So the asymptotes come from the dots on your midline. You have 1, 2, 3, 4 of those. Use those 4 dots for your asymptotes. And again, the dots that are not on our midline become our parabolas. So this dot, although it's on my x-axis, is not on my midline, right? So those dots become the starting of a parabola that goes away from my midline. Questions that you have for me? All right, your assignment tonight is a worksheet.